All right, friends, we are live here at Millbury High School, and we're taking 3.1 to 3.2 vocabulary notes, and we're just talking about some big ideas that have to do with functions. Now, functions are pretty important because functions are something that are predictable. I mean, for example, if you went over to the light switch and it was dark, and you flipped the light switch, you would expect the room to become bright. And that just makes sense, correct? You wouldn't expect to turn on the light switch, okay, and for your car outside to start. That wouldn't make any sense. You wouldn't expect to flip the light switch on and it's dark in your house, right? And, I don't know, your bed becomes made instantly. That doesn't make any sense. Not logical. Be cool, but it's not logical. Now, functions are things that just repeatedly are very predictable. So I want to start with a little anecdote about Dunkin' Donuts, okay? And they have some pretty decent iced coffee there. Now, let's say you went to Dunkin' Donuts and you asked for a small frozen coffee, right? Small frozen coffee. And a couple of things happen. One day you go there and you get a large frozen coffee. Well, maybe that's a good day, okay? So that's on Monday, okay? On Monday, you get a large frozen coffee. Then on Tuesday, you get a hot tea. You ordered a small coffee, but you got a hot tea. And then on Wednesday, they gave you a bottle of water, but you ordered a small frozen coffee. And on Thursday, you order a small frozen coffee. They give you half of one small coffee hot. And then you order a small frozen coffee, and finally on Friday, they get it right, and they give you that small frozen coffee, okay? Now, I'm asking you this question, okay? Is this Dunkin' Donuts functioning properly? Is this a function or no? It's not. It's not good. So this is not a function because you have one input. What's the input every time? What are you saying? Every time the input into that drive-through or whatever the heck it is, you say small frozen coffee. And every time the output is what? Different. It's not consistently giving you the same output, so you have 5 outputs for one input, and that's not a function, okay? That doesn't make sense. This is like going and putting cookie dough into your oven and getting out Doritos. That doesn't make sense. One day you get cookies, and the next day you get Doritos, even though you put cookie dough in both days. That's weird. So our oven is very predictable, is that it functions properly. It doesn't burn stuff. It comes out with, you put cookie dough in there at 350 for 20 minutes, you're going to be in pretty good shape, right? You're going to have some golden cookies. They're going to be great, delicious. So that's what a function is. So the domain is the set of all numbers or the set of all inputs, okay, for a function. So let's define domain as the set of all inputs. Often they're x's for a function. Okay? So we talk about the domain of an oven being like pizza dough and sauce and lasagna uncooked and cookie dough, and we could put nachos into the oven, but we don't expect to put a shoe into the oven or a math book or, a kitten. That just doesn't make a lot of sense. You shouldn't do that. Okay, don't put explosives in the oven. The domain is all the things that you normally would put into that function. The range is everything that would come out. Now, you expect to open the oven and find certain things. You don't expect to open the oven and find, I don't know, a rolly chair, okay? Imagine my rolly chair. You don't expect to open the oven and find a calculator just cooked right up and melting, okay? It doesn't make any sense. You don't expect to find a glass of ice water when you open the oven, okay? Doesn't make sense. So range is the set of all outputs. Set of all outputs. And usually they're labeled as y for a function. Okay? Set of all outputs for a function. Now, you might remember in science class, don't forget to put the date here, okay? Right here, you're going to put the date. Don't forget that in science class, oftentimes they'll talk about independent and dependent variables. So I want to talk a little bit, and I wanted to give you a nice little drawing here of my friends, Tom and Jerry. Are you familiar with Tom and Jerry? Tom is a cat, okay? Here's Tom, okay? He's a cat, and he's always chasing after my friend Jerry, who is a mouse. So he's got these like mouse ears, right? Looks something like that, maybe-ish. Except, yeah, and he's got the like tail and stuff. Okay, so I think that's pretty good actually. Except Jerry's a lot smaller than that. Okay, so here's Tom and Jerry. Tom and Jerry. Now, here's the deal. If Tom wants to catch Jerry, I guess what I want to ask you is who is independent? Who is free? Who gets to go wherever they want to go? Is it Tom or Jerry in this scenario? Yes. Jerry. Jerry can decide to run up the wall, or he can run under the table. He can run anywhere around the room he wants, correct? Jerry is trying to escape. He's free to go any direction. Now, Tom, if he wants to eat, if Tom wants to eat, what must he do? He must follow Jerry. He has no choice over what happens. He has to follow him. So the independent variable, right, is basically your input. Let me try to think of a better textbook definition for an independent variable. Sometimes I say things a little vague. So the independent variable, I'm going to say, is the input, and it can be any value in the domain. Okay? So I guess what I'm asking for you is, what do you have the choice over? Do you have the choice over, what do you control? Do you control what you put into the oven or what you take out of the oven? In a sense, you control both, but what do you really have control over? What goes in, right? You have control over what goes in, and that determines what comes out, correct? You can't put one thing in and determine to get another thing out. You have control over what goes into the oven. You have control over the input. You have independence. You're free to choose that, just like Jerry is free to run anywhere he wants. What do you think the dependent variable is? What do you think the dependent variable is? Yes? Yeah, the output, exactly. And it represents the output. So the dependent variable is the output that depends on the input you choose. It depends on the input you choose. You get to choose whatever input you want, right? But this is going to depend on that. Choose, two O's, right? Yeah? Okay. So that's independent and dependent variables. So let's take a moment and try to talk about independent and dependent variables, see if we can understand a few examples like that. So let's try to understand this example, and we'll talk about independent and dependent variables here in domain and range. This function represents the amount in fluid of juice, the amount of juice remaining in a bottle after you take X gulps. What do you control? Do you control the number of gulps you take, or do you control the amount of juice? I know in a way you control both, but what do you physically have control over? Tyler? The number of gulps. The independent variable is going to be X, the number of gulps. Okay? Now, of course, if you pick up the juice and you gulp it, like you just chug that thing, what's going to happen? I mean, depending on whether you're really thirsty and you chug it, or depending on whether you're really not thirsty and you take little baby sips, what is going to happen? What's going to depend on that? The amount, right? The amount of juice. So that's independent and dependent variable. You control the amount of gulps you take, and that's going to change the amount of juice in the bottle. You choose whether you take a tiny little sip or you take 5 huge gulps, right? That's your choice. You're just like Jerry in that sense, right? And Tom has no choice but to depend on the number of gulps you take. You take a lot of gulps, there's not going to be a lot of juice. You take very few gulps, there's going to be plenty of juice left. You can share it with a friend. Make sense? So if the domain is 0, 1, 2, 3, 4, what is the range? So if this is the domain, is that the input or is that the output? The domain is the x's and the input, or the domain is the y's and the output? Which is the domain? Which is the domain, friends? So we know the domain is the x's or the inputs, so we're just going to use these x values, basically. These are all x's, right? And I guess I'll just say that these are all x's. And I'm going to put them in here, okay? So my range, these are all my inputs. 0, 1, 2, 3. These are all in the domain. Now the range is what comes out, right? The range is what comes out. So if I put in 0 here, okay? I'm putting in 0 for x here. Well, I have 0 plus 12, don't I? 0 plus 12, so I just have 12. That's in the range. If I put in 1, I have negative 3 plus 12. So negative 3 plus 12 is 9. That's in the range. 9 ounces of juice. Okay, it was a 12-ounce glass, I guess, right? If I take 2 gulps, well, that's going to be negative 6 plus 12, right? If I take 2 gulps, it's going to be negative 6 plus 12. So there's going to be 6 ounces of juice left. And if I take 3 gulps, that's going to be negative 9 plus 12. So, whoops, sorry, that's ugly. Negative 9 plus 12 is 3 ounces. And that's all there is left for juice. So that's the range. The range is 12, 9, 6, 3. Does that make sense? Yes. Okay, I'm noticing now, thanks to a helpful student, that I left out 4 from the domain, which makes sense because there's still juice in that glass, isn't there? So don't you have the choice to take another gulp? So 4 is in the domain as well, and if we take 4 gulps, how much juice is left? None. So I'm just going to sneak that in there. This is cheating a little bit. I'm going to put commas in here and make that happen. Now there's no juice left, okay? So can you take another gulp from the glass? So you can't take 5. These are not in the domain. You can't take 5 or 6 or 7 gulps because there's no juice left. So this is not in the domain. It's not possible because you can't have negative juice, right? You can only have 0, a glass that has nothing left in it. And then you must stop. So you can take 0 gulps, 1 gulp, 2 gulp, 3 gulps, or 4 gulps, but that's it. Then you're out of juice, considering that they're consistent gulps. Okay? All right, so I'm going to try to wrap this up here because I don't want to give you too much information. What I would say is for you to try this problem. Oops. So why don't you try this problem? You'll pause the video, give this a shot, and then we will finish the video here. So we'll wrap things up. So pause the video, try this problem, and I will see you soon. Peace.